and welcome back. In this lecture, we will explore how the endocannabinoid system impacts metabolism. There are some biphasic results which are unsettling to people who enjoy symmetry. However, using the axioms of evolution within complex systems, we can start to make sense of the contradictory results. So our first learning goal would be to describe how cannabis is likely to influence metabolism, generally speaking. Then, using the concept of sensitive dependence on initial conditions, explain the paradoxical results of chronic cannabis use as it pertains to metabolism. Finally, state the general role for how CB1 and CB2 activation affects glucose levels. Before we learn about the ECS's impacts on metabolism, we need to reorient ourselves with some background knowledge. First, metabolism is a reductive term that means all chemical reactions. So another way to say it would be the current configuration of the system at a given moment in time. That would be metabolic state. Basically, what is going on and what does that mean? Recall that the reason for chemical reactions can best be explained by the following, right? So agents exist in an environment with limited resources, which are needed to facilitate the goals of an agent. All the goals of the agent are aligned with reproduction. As a population of agents will have limits and varieties of limits for different system settings, often called genetic variation, for most populations, variety in genetic programs is a requirement for long-term success. However, this means that within a population, some individuals will be more or less fit within the current environment. All agents employ genetic programs which couple energy-releasing chemical reactions with energy-requiring chemical reactions. These things are always linked. So, evidence suggests that for most all agents, ECS activation changes the system state to one of energy storage. One of the main ways this happens would be from perceptual changes. CB1 stimulation leads to system changes within the brain which are manifested by increased feelings of pleasure associated with food intake. By itself, this is a good way to ensure increased energy storage. However, also changing the control parameters associated with feelings of being full would lead to better results. Thus, if one purpose of ECS stimulation is to lead agents to consume and store food, this goal would be better accomplished if, quote, feeling full, end quote, was diminished. Why would this system state even evolve in the first place? So we can do a thought experiment to generate possible reasons why. It may be related to runner's high. Yes, much of the endorphin rush people get from running or other similar type aerobic activity is cannabinoid created. So your runner's high, you can thank your endocannabinoid system. It's no secret that humans are amazing long-distance runners because it represented an attractor state of evolution in many warm environments. So wound the animals and run them to death. We can sweat and they can't. I think by now you can explain how a positive feedback loop would emerge based on these interactions, leading us to be hairless and great runners. And possibly why ECS stimulation makes you hungry. However, it may be the case that during the evolution of species, the ECS was used to modulate these pathways of hunger and being satiated. And if someone just happens to consume cannabis to trigger these systems beyond their normal tonic control, it leads to somebody being really hungry and not feeling full. So, we've made some arguments for different reasons, and perhaps in the future science will have completed the experiments to support one of these ideas, or maybe something else completely. Beyond the effect, there are effects of ECS stimulation which point to the opposite result from what one would expect from being hungry and not full after consuming cannabis. Chronic cannabis users typically have lower fasted glucose levels and smaller waistlines as compared to non-users. Here we have a contradiction of effect that is related to scaling and signal integration. One would assume that if you have populations of individuals who exist in a state of intense food cravings and a lack of feeling full, that obesity rates among these populations would be high. No pun intended. But the macro data does not fit what we expect to happen based on how it influences affect towards food. So there needs to be other things going on besides affect towards food. We can go back to one of the fundamental tasks of living creatures, maintenance of homeostasis. So here, maintenance of homeostasis pertains to changes in ECS receptor expression. So this is a form of tolerance if you want to think about it. Chronic cannabis users show significantly decreased levels of receptor expression in many locations, including on the liver and pancreas, and the brain. Given that ECS modifies signals, and this happens rapidly, chronic users then would create a system state which has a low ECS expression to counteract the high levels of cannabinoids present within their bloodstream. This then leads to a new system state with less overall glucose and energy usage compared to non-users, right? Because the body is down-regulating the ECS, and so it counteracts the effect from consuming cannabis, or at least from consuming excess cannabinoids. Extending this dimension into our current environment for humans, at least in America and Europe, right, and many other spots, we have an abundance of food and a lack of physical activity. And this is common to most humans. So chronic cannabis users may inadvertently provide themselves with benefit in this current environment as compared to a non-user. Now this is at least for this set of measures for metabolism and health. Now that being said, it could just be that chronic cannabis users, generally speaking, have system states which tend to not lead them into binge eating. One potential con of having lower glucose levels and then consuming cannabis would be a rapid heart rate. Low glucose is a stressor and causes a release of epinephrine and adrenaline, presumably to make you awake and alert to look for food. Now this leads to a rapid heart rate. This pathway, though, may help to contribute to the freakouts experienced by novice users who consume a chronic level type dose of cannabis. However, that all being said, a rapid heart rate can be offset by eating a small snack. The heart gets first dibs on blood and oxygen and is sensitive to new signals. Thus, a snack can help reset this pathway and decrease unpleasant feelings associated with rapid heart rate from the adrenaline release. Another benefit to low glucose levels would be the inhibition of most all types of tumors. There are only a select few types of cancers or tumor growth conditions which would not be hindered by chronically lower levels of glucose. Another way the ECS affects metabolism would be how it influences leptin and the hypothalamus. Leptin is a hormone produced by fat cells, and its signal is modulated in different ways by cannabis. The ways it modifies leptin release depend on the initial conditions of the system, i.e. the person. Nearly any combination of system states can happen with ECS stimulation and its impacts on the stomach, the hypothalamus, and adipose tissues. Now, we've observed these systems independently and under such few conditions that are helpful as it pertains to understanding the role of the ECS. So, no axioms can be currently extrapolated from the body of knowledge of science. Adding to the complexity would be the biphasic roles of CB1 and CB2 receptor stimulation. CB1 stimulation leads to decreased glucose tolerance. However, CB2 stimulation leads to improved glucose tolerance. Recall that receptor expression varies based on tissue type, time of day, the environment, and here, one major aspect of the environment would be exposure to exogenous cannabinoids, i.e., are you a chronic cannabis user? So again, there are too many possible system states with a lack of observations to extrapolate useful axioms for prediction. One large-scale study on the impacts of blocking the CB1 receptor has been completed. So if you recall from the previous slide, CB1 stimulation led to a decrease in glucose tolerance. So a decrease in glucose tolerance would mean that you're going to be storing energy. So in this study, 625 overweight or obese patients, so here BMI of 27 to 40, were given either a placebo or a CB1 receptor blocker. In overweight humans, CB1 receptor blocking improved glucose tolerance, increased HDL by 10%, and subjects lost 8.5 pounds on average compared to the 2 pounds lost by the placebo group. It would be beyond this course to untangle the web of knowledge surrounding fats, carbs, and obesity. However, an increase in HDL is a good thing. It's the one that takes excess cholesterol from cells. The LDL is the one which delivers cholesterol to the cells in the body. So what we can say is a decrease in the total consumption of fats and carbs should lead to a decrease in the total cholesterol intake, with an increase in HDL because of there being less LDL and less energy storage requirements because of the decrease in overall energy intake. So what I will state is that it's very stressful for your body to deal with chronic excess of carbs and fats. And the process of fat storage from excess carbs stresses out adipose cells, which leads to the immune system attack of organs and areas with excess materials, and this kind of leads to chronic low-level systemic inflammation. And anyways, let's go back to the study. This study saw a very large dropout rate. Now, the reason why they dropped out is very interesting because it has some secondary implications. The main reason for the large dropout would be the effects of pure CB1 receptor stimulation within the brain. This causes mental health changes, all right? Pure CB1 receptor stimulation is equivalent to using spice. So, if you don't know, spice is hemp sprayed with CB1 receptor activating molecules. So the media often likes to report on synthetic marijuana, called spice, and its history is littered with adverse effects reported by users. Extreme paranoia, extreme rapid heart rate. Basically all the negative effects of cannabis highlighted and intensified by spice. Cannabis use cannot. Let me say that again. Cannabis use cannot be usefully compared to what reductive scientists thought was its mechanism of action. The process of reductionism led scientists to mistakenly infer that the impacts of cannabis had to have been purely from the effect of THC, which is largely responsible for the CB1 stimulation. So, now hindsight is 2020, and this drug is no longer used. And by that, I mean the drug used in the study is no longer used. It caused mental health issues in populations. Yet there are still many studies being conducted that use pure CB1 or pure THC exclusively, right, to try and make sense of cannabis use. We can't make useful predictions from these studies. We can only learn about the parts, but not how they fully integrate within the system. These studies are very flawed. So going back to this study here for a moment, it's a great example of how understanding systems requires context, and that it is improper to assume scaling of results and impacts on other levels. Right? This study highlights that by showing that cannabis shows conflicting results at different scales, and that complex adaptive systems will evolve and try to maintain homeostasis. And so the concepts of evolution and homeostasis must be taken into account for all chronic users in all studies. In summary, chronic cannabis users typically show lower prevalence of obesity, lower rates of diabetes, and lower fasting insulin levels. An explanation of these results deals with CB1 receptor regulation. Chronic cannabis users have decreased CB1 receptor expression in the brain and in other areas. So this is an important thing to keep in mind when comparing chronic cannabis use to mild cannabis use to first-time cannabis use. Finally, this lecture helps to highlight the importance of using complex system methods over reductive science in understanding our ability in understanding systems and for improving our ability to predict, which is the point of science.